All right, so let's take a look at just a couple examples. Just didn't quite get finished yesterday, so that's what we're going to do. We did example 1A, so let's do example 1B. So example 1, and we're going to do part B. So, oops, kind of looks like this. And here's what they tell you. We have to determine whether this is a parallelogram or not. If that's all you saw right there, right in front of you, and they asked you on a quiz or a test or a homework problem, is this a parallelogram? Could you say 100% sure that that's a parallelogram? You give me thumbs up? Why? Why is it a parallelogram? Do you know they're all right angles? Okay. So it sure looks like it though, right? Sure looks like it's a rectangle, doesn't it? And it really is, because on this program that I used, I hit a button to make it a rectangle. But just looking at it, you cannot assume that it's a rectangle. And who knows if that angle is like 89.0 or 0.99999 degrees, right? And it may not be exactly 90 degrees. So we don't know for sure. So you have to only go by the information that they tell you, that they give you. You're not. Oh, where are the other boys? I thought maybe they were at that meeting, because everybody that's absent is a football player, so I figured maybe they were in there. Okay. Are others coming back now? All right. So here's the information they give you. Let's put it in a different color. Where were you guys? So where were you is the question. Okay, thank you. All right, what if they tell you this, that this and this are equal, and this one and this one are equal? Can I say that this is a parallelogram or not? Because it might not be, but it might be. Here's the information. Here's what they tell you that's true. Does that make it a parallelogram? What do we know about the angles of a parallel? In order to be a parallelogram, what do we know has to be true about the angles? A couple things. The opposite angles must be what? Equal. Are the opposite angles equal here? No. Because this has two arcs and it has one arc, that means that they're not the same. Everybody got that? So this one and this one are not equal. This one and this one are not equal. So what does that tell you about this thing? That it's not a parallelogram. Okay? Everybody got that? All right, so this is definitely not a parallelogram. So what would I say? I would say no, it's not a parallelogram. Or you could say not a parallelogram. Does that make sense? Yeah, pretty good. All right, here's another one. And it kind of looks like the same picture. Pretty much is. Oops. There we go. There we go. But they give you different information. Let's go back to red. This one, they tell you that this and this are right angles. So that's the information they tell you. It's not just a blank four-sided figure. They do tell you a couple things about this. Is that enough to say that this is a parallelogram? At first glance, it doesn't look like it, but you got to think a little bit. You got to dig deep a little bit. Why, yes? Give me a reason. Because I don't know anything about the opposite angles, do I? So I don't know the opposite angles are equal. I don't know that they're not equal, right? Because just because it doesn't have a mark doesn't mean that this is not equal to that. Okay? But what about these? Give me a name for angles that are next to each other like this. Consecutive angles, right? So what's true about these consecutive angles? They add up to 180, which means they are what? They're supplementary, right? They're supplementary. So that's good right there. So these consecutive angles are supplementary. Agreed? Which means that this and this have got to be parallel to each other. Yes? All right. And actually, I was thinking, I didn't even look at my notes. I was thinking that this was a parallelogram, but then I started looking at it. I'm like, wait a minute, I don't know enough information. Then I looked at my notes, and sure enough, just because these two are supplementary, does that mean that these two are supplementary? Does it mean that these two right here are supplementary? It doesn't mean that at all, does it? Does it mean that the opposite angles are equal because these are parallel? Now that I'm thinking about it, hold on. Yeah, okay. So these two right here are still supplementary, but does it mean that they're both 90 though? It doesn't mean it. Because here, let me draw a picture for you that shows you that you can still have two parallel lines and two right angles, but it's not a rectangle and it's not a parallelogram. Do you think you could draw one? Watch. What if I drew, there's that side right there, okay? And then I drew a right angle here and a right angle here. Isn't that what this is given? But look, this side could extend out further, couldn't it? Or it could be shorter than this. So I could still have a four-sided figure with two right angles in here, but it's not a parallelogram. Is this a parallelogram? No, it's not. Even though that these two sides right here are parallel to each other, does that necessarily mean that these two sides are going to be parallel? No. These two angles right here are supplementary. It's absolutely true that this angle and this angle add up to 90, or add up to 180, sorry. But does that mean that they're 90 degrees each? No. Okay? So they call it a counterexample. I just drew a counterexample to this, okay, to this being a parallelogram. So it's got the same information that this does, but I could draw a four-sided figure with two right angles, two parallel sides, and it still not be a parallelogram. So what was your answer on this one then? Is this a parallelogram? No, we don't know. It could be, but it doesn't always have to be, right? This could be a parallelogram, but I could draw the same situation with the same two right angles, the same two parallel sides, and it not be a parallelogram. So I would say no, all right? It's not a parallelogram. Let's do the same thing over here. I was going to do this earlier and I didn't, but now I did this one, so I figured might as well. What if I drew this? I want to draw a four-sided figure. Let's make this a little smaller. Boom. Watch this. Can I draw a four-sided figure, a quadrilateral, where both of these angles are equal? Yeah. I could draw it where both of those angles are equal and both of these angles are equal. Does that mean this thing is a parallelogram? No, it's not. Okay? Do you see that? So this is kind of like my counterexample, all right, where I have a four-sided figure with these two top angles equal and these two bottom angles equal, but it's not a parallelogram. Everybody got it? Okay. So that's what they want you to do. They don't ask you to draw the counterexample, but it's nice to see it. Let's do something with some numbers in it. That's what we're waiting for, right? Maybe, maybe not. Maybe you just like the idea of just saying, yes, it's a parallelogram, or no, it's not a parallelogram. Might be a little easier. But let's do this. Example 2. This is a two-parter, A and B. And then once we're done B, then that's it for today. Let's get this to slant a little bit. Yep. All right, let's put some diagonals in here. So there's one diagonal. There's another diagonal. And let's label it QR. Let's see, it's QRS. Oops, not T. This is P. PQRS, okay? And they tell you some stuff about this. They tell you something about the parts of the diagonal. This is kind of what we did yesterday. But this is actually a little easier. This is 6b plus 2. and this is 7b minus 4. All right, here we go. Do you remember yesterday we did that substitution stuff? Yes? All right. It wasn't that hard, but it was different than what you've done before. This one is very similar to what you've done before. So this is kind of what would be on a quiz or a test. All right. I don't think I put a substitution problem on a quiz or a test. So that's nice, okay? Cabrie's like, yeah. All right. But that's all right. So you should be able to do this one, though. So I tell you what, I'll give you 1 minute. Ready? Go. You got 1 minute. I want you to solve for A and B. So this is a parallelogram. They tell you. Okay, I should have said that right at the beginning. This is a 20, yes. So this is 5A, this is 20, this is 6B plus 2, this is 7B minus 4. All right, so I want you to solve for A and then solve for B.
What's the number in the letter?
7B plus 2 is on the left, bottom left. 7B minus 4. It's QRSP. Oh, the middle one, T. Sorry, it's T. I didn't put it in there. But all you have to do is just solve for A and B. 5A, 20, 7B minus 4, 6B plus 2. Well, that's what this length is. PT is 6B plus 2. This length right here, TR, is 7B minus 4. This length, QT, is 5A. And this length, TS, is 20. So you should only have to do 2 simple little algebra problems to get A and B. You don't have to do any substitution. It's not complicated. It's real basic. Was Judah Johnson with you guys? Okay. All right. You should have A right away, right? You shouldn't even have to do any work for that. You should just be able to look at it and tell, I think. Maybe, maybe not. But I always tell you to show your work anyway, right? I wrote a lot of show your works on this last homework thing that I passed back to you. Did you see it on yours? All right, start showing your work, okay? Not every problem you can show work, but there's a lot of problems where you can. If you have to solve for X, solve for Y, solve for A and B, you got to show me what you're doing, all right? I'm not going through every single problem, checking to see if they're right. I'm just glancing at it, okay? I grade homeworks pretty quick, right? But if all I see is just a whole bunch of answers, and I know there's a clump of them where you need to do some work to show how you got the answer, I'm looking at that and I'm saying, you didn't show your work. So I take 2 points off if you don't show your work. All right. Some of you guys know more than others. Some of you guys always show your work. You never see 2 points off. You always see a 5 on there. All right. All right. Enough time. Let's do A first. So how do we set this up? What is true about 5A and 20? They're equal. They're the same. They're equal to each other. Let's say equal to each other instead of the same. All right. So 5A equals what? 20. Easy math. Easiest math you've ever done, right? Divide by 5, divide by 5. A is 4. So everybody should have gotten that. Yes? All right. B is a little bit more difficult, but hardly. So what's true about these two? Yeah, and why are they equal? I kind of skipped over that. Why are they equal to each other? Because the diagonals of a parallelogram bisect each other. Exactly right. So they bisect each other, which means they split each other in half, right? Or into 2 equal parts. So this one and this one are equal to each other. So let's do it. I like to put the bigger number first. So 7b minus 4, I'll put that on the left. Doesn't matter, you could do it either way. Equals 6b plus 2. I just like to put the bigger number on the left so that I can just move everything to the left. That's the only reason. So what do? Subtract 6b. I'm not going to give any explanations. You should be able to do this already. Add a 4, add a 4. Okay, 4's cancel, 6b's cancel. 7b minus 6b is 1b, or just b. 2 plus 4 is 6, and there you go. You are done that example. You're finished it. Yes, sir. All right. you have a question, or you're just you're just writing it out? Oh, okay. I thought you were trying to think of what you were going to ask me. I'm going to move it up just a tad. You got the A though, right? It's the B. All right, let's do one more. So that one's about the diagonals. This one does not have any diagonals. It's on this one, you're going to have to do some substitution. All right, but that's good because you just learned it yesterday, so it's good to do it again. I betcha. You done with that, Silas? Okay. So now we are going to do some substitution on this one. But hopefully, after we do it today, you're going to like, oh yeah, I thought it was really hard yesterday, but now I kind of get it. I'm hoping anyway you say that. Maybe you will, maybe you won't. So the top is 2x. The bottom is y plus 14. The left one is x plus 11. And then the right one is y. Tell you what, I'll get you started. Okay, we'll set it up first. Then I'll give you a minute or two to try it yourself. This is going to use substitution. It's the stuff that we talked about yesterday. So let's do the left and the right one. So what would I do with that? What's true about both of those? Drew? What's that? You had your hand up. What do I do? Clea, what do I do here? Set them equal to each other. That's right. So x plus 11 equals y. I'm going to do it a little bit differently. I'm just going to go y equals x plus 11. Is that all right? Why would I do that? Well, it's not to get both the variables on the left side. I just want one variable by itself on the left side. So if I write y equals, it's already on the left. It really doesn't make any difference. Okay, it just looks a little bit cleaner. That's the only reason I did that. Everybody agree? X plus 11 equals y. Y equals x plus 11. It doesn't matter how you write it. I just think it looks a little nicer this way. All right? And let's do the top and bottom one. And since y is on the left-hand side of this one, guess how I'm going to write this one? Y plus what? No. Y plus 14 equals 2x. You could have done it the other way. It wouldn't make any difference whatsoever. You could have written 2x equals y plus 14. The only reason I did this is just since I got the y's on the left up here, I'm going to put the y's on the left over here. It doesn't make any difference. All right, I'm going to give you about a minute, and then I want you to solve for x and y. It's all set up for you. You're going to use substitution. All right, y is already by itself. I'll give you a little hint. I'm almost doing this for you. So y is equal to this. What am I going to do with that? Put it in for what? For y in the other one, right there. All right, you do the rest. Is your hand up this time? What is it? Of course you do. No. You came in late. You're going to stay here and you're going to work on this. I think you can hold it for a while. Everybody should be trying this. I see people not writing anything down. Everybody should be trying this. Come on, play along. Play the game. It's not a game. It's serious. Life and death. Once you do that first substitution, the rest just kind of falls into place. It's really easy. You just have to understand this thing right here. Take what y is equal to, substitute it in for y in the other equation, and then you should be good to go. So once you do that substitution, you solve for x. Did anybody get x? Amaya, what'd you get for x? Did you get it? 25? You sound like you're not sure about it. You're not? You should be. You should be confident because you are right. It is 25.
Is y 36?
Yes. And y is 36. So let's show you how to do it. So what we're going to do is we're going to take what y is equal to, which is x plus 11. We're going to put it in for the y in the other equation. So instead of y plus 14, what are we going to write? X plus 11, right? Because that's what y is, plus what? 14 equals 2x. So all I do is just rewrite, all I did was rewrite this equation but I replaced or I substituted what y is equal to in for that y, correct? I just substituted x plus 11 in for that y. So there's my y, there's my plus 14 equals 2x. And now it's pretty easy now. So it's x plus, what's that? What is it? 25, right? Yep. X plus 25 equals 2x. We have to get x on the same side. So I'm going to subtract an x from this side. I'm going to subtract an x from this side. That x cancels out. I'm left with 25. That equals 2x minus x. What's 2x minus x? It's x. So x equals 25. Now I have to solve for what? Now I got to solve for y. Do I have y by itself somewhere in here? I do, right here, don't I? Everybody see that? So I kind of know what y is. So I'm going to write y equals, it's x plus 11. Well, I just found what x was. So I'm going to replace this x with a 25. So it's just 25 plus 11. And you do that math, and that's 36. And that's how you get both of those answers. Now, they don't ask you on this, but what if, and I could ask this on a quiz or a test, what if they ask you to find, watch this, they could ask you to find 4 things. Find AB, find CD, find BC, and find AD. What does this mean when I just say AB with no line over top of it? What does that indicate? Okay, the length of the side, right. I'm finding the length of side AB. So when there's no thing over top of it, that automatically means I'm finding the measure of, or the length of, line segment AB. Everybody with me on that? So they don't have to write the words, find the length of. They just put AB with no line over top of it. That means you're finding the length of AB. So how do I find AB? Well, I find that. Well, that's the same as that, isn't it? So how much, if I could talk. Getting too excited about this, I can't talk. So y is equal to what? 36. So that means what? CD is what? 36. What's AB without doing any math? It's also 36. Okay? So what is BC? Is it 25? Why 50, Neil? That's right. It's 2 times 25. X is 25. This length right here is 2 times 25, which is what? 50. So the length of BC is 50. Without doing any arithmetic at all, what's the length of AD? It's 50 because the opposite sides are equal to each other on a parallelogram. If I wanted to, I could plug it in, couldn't I? What is y? 36. What's 36 plus 14? That's a 10. That's a 4 and a 1, right? It's 50. It works, doesn't it? Yep. So either way you do it. So they could ask you this. They might not just say find x and y. Or up here, find A and B. What if they ask you this? What if they ask you to find, let's do it over here, QS? What if they ask you to find QS and they ask you to find PR? All right? They don't on this example, but they could on a quiz or a test. I could put it on there. So how would I find QS? Well, first of all, this is 20, right? So what's 5A? That's 20. So what's QS? It's 40. That's right. This is 20. This is 20. The whole thing is 40. So that's right there. 20 plus 20. What about PR? I don't know either one of those, but I do know what B is, though, don't I? So let's put it into this one. That's probably a little easier. So this is 6 times 6. What's 6 times 6? 36 plus that 2 would be 38. So that would be 38. What would this TR be? It'd also be 38. And then what do you do to find the whole PR? Add them up. And that's what? 76? Is that right? So that would be 76. So they could ask you those things as well, besides just solving for A or B or X and Y. Everybody good? All right. So your homework, let me flip the page, is 18 to 25. So it's section 6.3. There's no A or B on this. So it's section 6.3, and it's 18 to 25. You have 14 minutes left. All right? You should, what's that, 8 problems right there? You should be able to do every one of those problems before you leave in 14 minutes. All right? So let's work on it now. Don't make me walk around saying, why don't you have paper out? Why don't you have paper out? Let's work on it right this second. So get some paper out. If you didn't bring any, see if you can borrow from somebody else. Okay? This is your time to work. It's not time. It's not free time. It's not free time. It's not time to just mess around and wait till the bell rings. It's time to work. And if you don't, I'm going to start the next lesson.